Hi Professor, my name is Rose Torres and this is my presentation on the light reaction. So I'm just gonna get my tripod and record the screen of my iPad. Couldn't have anybody to help me. So the goal of the light reaction is to convert energy from the sun into chemical reaction so we can create NADPH and ATP. So the first thing we do is the sun is going to release energy in the form of photons into the chlorophyll molecule of both reaction centers of photosystem 2 and photosystem 1, and then these have electrons that are always super excited, so they like to leave, and then they also go down these electron transfer chain, both of them from electron transfer chain from photosystem 1 and photosystem 2. So these electrons from photosystem 2 like to leave the thyroid membrane, and they go into the stroma, and then they combine with NADP plus and a hydrogen ion to create NADPH. So then when these electrons were expelled out, it became unstable and highly reactive because it's missing electrons in its outer shell. So then that was photosystem 1. So it's going to steal some of its electrons from photosystem 2, and then photosystem 1 will have its balanced electrons. So then photosystem 2 will also be missing electrons. So it's going to get its electrons from a water molecule, and this water molecule is going to release its electrons when it's split by the help of an enzyme. So this photosystem 2 will get its electrons, and then this water molecule is going to be split, and it's going to create 2 hydrogen ions and a oxygen atom, or half an oxygen molecule. And then so these electrons are highly they have a lot of energy, so they have the ability to act as a pump. So it's going to get the hydrogen ions from the stroma and pump them into the thylakoid space. So then the thylakoid space is going to go from a well, they were hypotonic. They had the same amount of hydrogen ions. So then the thylakoid space became hypertonic, and hypotonic, and then compared the thylakoid space is going to have more hydrogen ions, so this is going to act as a solute and this as a solvent. This goes from a lower concentration to a higher concentration. So then so since this is going to have a high concentration of hydrogen ions, these hydrogen ions, they're going to want to leave so they can become stable, and they can have the same amount of solute on both sides. So then these hydrogen ions are going to leave through the ATP synthase, and like when all of these hydrogen ions are up here, it's going to cause this ATP synthase to spin. So it's going to spin, and it's going to combine ADP and a phosphate, and it's going to create an ATP. And then we have to do this a total of 12 times. So once we do this a total of 12 times, we're going to create 12 ATP, 18, I'm so sorry, it's 18 ATP, 12 NADPH, and 6 water molecules.